There are a few problems that I want us to work through together for 9.4, just to kind of figure all this out because there's a lot going on. First thing I want us to do is number 5 here. It's supposed to find the critical chi-square values. That's what these are. They're not x. It's chi, C-H-I. It's a Greek letter. Chi-square for 1 minus alpha over 2 and chi-square for alpha over 2 for the given level of confidence in the sample size. So let's practice that. Basically, we're finding critical values. We've already learned how to find, in case you'd forgotten, this guy right here. That's a critical value. That's Z from chapter 9.1. And then 9.2, we learned how to find critical t values. Isn't that great? 9.3, it's the same as 9.1. That's why we do 9.1 actually, right here. Critical z value right there. 9.1 and 9.3 are the same thing. Oopsie, didn't mean to do that. That's okay. And then now 9.4. Okay, so the first thing we're going to have to write down is our confidence level. Our confidence level for this problem is 0.90. That means alpha is the complement of that. So I'm going to take 1 minus that. That's alpha. Alpha over 2 is equal to, sorry, I'm doing two things at once here, equal to that number divided by 2. And I use cell references. I've been using them throughout the tutorials, and that's because, let's say at a later date I want to change this to 99, everything else will change automatically. That's the beautiful thing about using cell references, to do something like that. Okay, so that's alpha over 2. So then we're going to need also, in case you didn't spot it, there's chi-square for alpha over 2, and there's also chi-square for 1 minus alpha over 2. So we're going to need 1 minus alpha over 2. And by the way, just in case you really feel like doing it this way, you could always insert, here let me maximize so you can see, a symbol. My computer's being a little possessed, so I had to pause that for a second. But you can insert, see there's alpha right there, right next to beta and epsilon and nu. So it's in here in the Greek letters. So if you want to insert it as a symbol, or if you want to type the word alpha, knock yourself up. So 1 minus alpha over 2, that would be equal to 1 minus this guy right here. Okay, so there's alpha over 2, there's 1 minus alpha over 2. The next thing we're going to definitely need is our degrees of freedom. Degrees of freedom. Now in this particular problem, let's see what it was. It's 19, right? Degrees of freedom is n minus 1, right? So you can type it in from the start, or you could put n up here and say it was 20, and then make this guy down here equal to that value, take away 1, whatever. But either way, you got to get 19 for this problem. Okay, there's the degrees of freedom. Now we need our critical values. Now there are two critical values. There's the alpha divided by 2. And again, if you don't want to type alpha, you can go get the Greek letter yourself. Chi-square value. Okay, that would be equal to, okay, now we need chi inverse. It's this one right here. See, chi inverse. Inverse functions have been the ones we've always been using to get the critical values. So we use norm S inverse in 9.1 and 9.3, and we use T inverse in 9.2. So for 9.4, we use chi inverse. Now the probability here is going to be the alpha over 2, so that's this one, 0.05, comma, the degrees of freedom is right there, cell B6, 19. There we go. Then we need 1 minus alpha over 2. Oopsie, sorry. Crit value. That would be equal to chi inverse. And then now we need the 0.95 this time for our probability, and degrees of freedom is 19. And there we go. All right. So we have the chi for the 0.95 right here, and the chi for the 0.05 right here. All right. Cool. So those are the two critical values. This one's obviously lower, and this one's the higher one. That's okay. Right? The order doesn't really matter. All right. I will see you next time for another problem in 9.4.